With the increasing commercial availability of AgBots and the widely predicted benefits, AgEcon compared an AgBot spray system to conventional tractor with boom and self-propelled sprayers. Overall, our analysis showed that switching to AgBot spraying can be economically beneficial for both scenarios, with an internal rate of return of 13 to 16%. When considering the number of AgBots to purchase, the key consideration we looked at was maintaining the ability to achieve timely spray applications to minimise crop damage. We looked at the effective field capacity, which is the hectares sprayed per hour, and which considers the time spent spraying, refilling, refuelling and travelling, as well as any potential AgBot efficiency gains from their ability to rapidly react to appropriate spraying weather and field conditions. This showed that one AgBot sprayer could take 2.4 times as many hours as the self-propelled sprayer across all spray tasks, and 1.3 times as many hours as the tractor sprayer. So from this, we assessed the need for at least one AgBot to replace a tractor with boom system and 2 AgBots to replace a self-propelled sprayer. Looking at the benefits, these were largely dependent on predicted increases in yield from a combination of factors such as improved weed control due to more responsive spraying and a reduction in compaction. These yield increases accounted for about 75% of the total benefits. However, they depend on a complex interaction of factors affecting crop yield. As an example, the continued use of heavy conventional machinery for other operations like planting and harvesting could reduce the potential yield benefit derived from the lighter AgBots. Capital costs were the second largest benefit and accounted for about 10% of total benefits. These reflected the avoided purchase cost or prolonged useful life of the conventional tractor spraying systems. Reduced chemical costs also made up about 10% of the total benefit. However, these were based on the benefits of spot spraying technology, reducing chemical use per hectare. Spot spraying technology is not specific to AgBot systems and could be considered as a separate investment. Fuel and maintenance savings made up about 2 to 3% of total benefits. While the smaller AgBots used about 75% less fuel per hour than the conventional systems, this was largely offset by the lower AgBot field capacity, meaning more time spent to cover each hectare. Lower maintenance costs per operational hour were similarly offset by lower field efficiency. While labour savings are often the headline benefit of these automated systems, they were found to account for just 1 to 3% of total benefits. While AgBots removed the need for in-field labour, this was offset by the need for ongoing chemical refill and refuel labour. Overall, we found that AgBot spraying technology can be a viable investment for adoption in a cotton farming system. However, these results were heavily influenced by a number of factors, such as any potential yield benefits and chemical savings. As with any decision, farmers should closely review AgBots in their own operational context before investment.